Alright, so today's learning targets is that I can put an equation in slope-intercept form and I can graph the line using slope-intercept form. Alright, to do that you actually have to know what slope is. Okay, so the official definition for slope is thinking about the slope of a mountain. It's how fat or how steep the mountain is. So when we talk about slope in math, it is a rate of change of a line. And rate of change is just a fancy way of saying steepness. Okay, now there's a bunch of ways that we can represent slope. Okay, so we can find the slope of the line m by looking at a minimum of 2 points. Now some special things here. M will always represent slope in equations, functions, or formulas. Okay, so whenever you see an m, know that it represents the rate of change of the line, or the slope. Okay. The points are represented by x1, y1, and x2, y2. These subscripts, these are called subscripts. They mean nothing to other than identify which point we are looking at. So x1 is point 1, x2 is the x for point 2, y1 is the y for point 1, and y2 is the y for point 2. So don't mix those up, and you don't use those numbers for anything other than identifying. Alright, the first way that we know slope is that it is considered the rise or the up and down change in a line versus over the run, which is the left and right change of the line. Okay, now a rise can be represented by a change in y, and how do we represent a change in y in math? Well, we subtract the two things. How far away are they from each other? So y2, or a change in y, sorry. So change in y over a change, the run is the change in x. So how much is the x changing versus how much is the y is changing? And we represent changes using subtraction. So I subtract where I am from where I was, right? So at y2, I take y2, so where I went, minus where I was before, minus y1. That's the change in y. And then the change in x will be x2 minus x1. Okay, so where I am now versus where I was before, that will represent how much x was changed. Okay, so to actually find the slope, if we're given a line, we can take it directly off the graph using that rise over run. I want to find 2 points on my graph and compare how far away they are vertically versus how far they were away horizontally. So basically a change in y over a change in x. Alright, this graph, I have a point here that I can look at, a point here that are nice. We don't want points in the middle of lines because that's not whole numbers, those are fractions. We don't want to look at those. So it looks like I've got a pretty steady pattern of points along here. So I want to see the rise over the run. So I just need to pick 2 of them. So I'm going to pick these 2. Okay. So I want to see how far I go up. So here's my rise. Looks like I go up 2. And remember, up is positive, down is negative, right. So I've got positive 2 since I go up 2, and then to see how far my run is, so that was my rise, and now my run, I have to go over 1. Okay, so my run is 1. Right. So rise is 2, and run is 1. So my slope, m, rise 2 over run 1. And we can simplify this to just be 2, but it is rise over run 2 over 1. Okay, so I want you guys to pause the video real quick and try number 2 on your own. See if you can find the slope of it and then compare to what I'm about to do. Okay, so what you should have done was identified some points. I've got a point that looks like it's directly on there. I've got a point directly here, and that looks to be about it. Everything else kind of falls in between, so I don't want to use any of those. Alright, so let's find the rise. How far do I have to go up from this point to this point? Well, it looks like 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going up 7. And again, positive is up, negative is down. Alright, and for the run, let me make a note of that, that's 7. Your run you should have gotten over, so from here over 2. Okay, so 1, 2. So that's my run. Remember, x in the positive direction is to the right, and x in the negative direction is to the left. Since we went to the right, it should be positive. Right, and your final slope should have been rise 7 over run 2. Simplify that if you can, but 7 over 2 you cannot simplify, so it will stay as it is. Okay, the other way that you can see you can do slopes is if you're given just 2 points. You don't have the graph, so you can't just count rise over run. We actually have to use the slope formula from above. Okay. Now, m was equal to a change in y over a change in x, so my slope formula is m equals y2 minus y1 over x2 minus x1. Now there's a couple different ways you can do this, and I'm going to show you both. So there's direct labeling, so I want to pick a point 1 and a point 2. Okay, so I get x1, y1, x2, y2. Alright, so my x's I'm going to label in red, and my y's I'm going to label in green. Okay, so to find the slope, I'm going to take y2 minus y1 on top. So fill in your slope formula. y2 is 4, y1 is 2, and I'm subtracting them, over x2, and this is where you have to be consistent. It doesn't matter which ones you label, x1, x2, y1, y2, as long as you are consistent. So I've got x2 is 3, x1 is negative 2. Okay, so 3 minus a negative 2. Minus a negative becomes positive, and to find the slope, I just want to evaluate those two. So simplify as much as you can. 4 minus 2 is 2. 3 plus 2 is 5. Simplify if I can, but I can't. 2 over 5 is not simplifiable, so m is equal to 2 over 5. Alright, so I want you to pause the video and try b really quick on your own, and I'll go over it with you. Alright, so b, you get x1, you should have gotten x1, y1, x2, y2. Plug them into your formula. So remember, slope formula is y2 minus y1 over x2 minus x1. y2 is 2, you should have 2 on top, minus y1, which is 2, over x2, which is 3, minus x1, which is negative 1. So minus a negative becomes positive. Simplify as much as you can. So m is equal to 2 minus 2, which is 0, over 3 plus 1, which is 4. So my slope is 0. Okay, 0 divided by 4 is 0, so your slope is 0. Alright, the second way I wanted to show you how to do these is using arrows. So if you have trouble connecting which y's and x's or which one's x1, which one's y1, which one's x2, which one's y2, you can connect them. So starting at your point 2, I'm going to do y's, so draw an arrow to my two y's on top. I'm subtracting them. So I've got negative 3 minus 0. And then on the bottom, I'm going to draw an arrow between my two x's to represent that it is y's over x's, and I'm subtracting them. Okay, so on the bottom, I have positive 3 minus 0. Okay, and that is my slope formula, right? y2 minus y1 over x2 minus x1. Okay, so I get negative 3 minus 0, which is negative 3, and 3 minus 0, which is 3. I want to simplify this as much as I can, so I've got negative 3 divided by 3 is negative 1. That's my slope. Alright, so pause the video real quick and try D. Alright, so what you should have done is connect the y's. Y's, 1 minus 4 over x's. 2 minus 2. Okay, so we have 1 minus 4, which is negative 3, and 2 minus 2, which is 0. Now the problem with this one is I've got negative 3 divided by 0, and we already talked about how we can't divide by 0. So since this is divided by 0, there is no slope, or undefined slope. On a graph, this usually looks like this, straight up and down, so there's no change in x when you change the y, which means that it is undefined. All right.